To just compare the bonding and forces and the relationship to boiling point, this is what I want you to know. So I have columns of interaction, strength, boiling point, and examples. The strongest is network covalent. It has highest boiling point, silicon dioxide, quartz, graphite, diamond. Those are all examples of network covalent. Silicon dioxide, sand or glass, is about 2200 degrees Celsius. After that, the other interaction that is really strong is ionic. So far these two are intramolecular, and it has high boiling point. Sodium chloride, your table salt, for example, 1400 degrees Celsius. Then we come to molecules, simple molecules. Now they have attraction among them, known as intramolecular, intermolecular. The strongest is hydrogen bonding. When hydrogen is attached to nitrogen, oxygen, or fluorine, extremely small electronegative species or atoms. Their strength is moderate. Their boiling point is high. For example, water boils at 100 degrees Celsius because it has hydrogen bonding. And this is the water molecule. I put two of them together, and the red here indicates their hydrogen bonding. After hydrogen bonding comes a dipole-dipole, when you have dipole moment or a polar bond. Its strength is weak, boiling point is low. For example, iodine chloride, liquid, boils at 97 degrees Celsius. And iodine bromide or iodine chloride is negative positive, and the interaction, then again I put it in red, among the negative and positive poles of this molecule. Finally, the weakest of all is London dispersion. It's the weakest for nonpolar molecules. They also have intermolecular forces known as London dispersion. For example, I put bromine. Momentarily, the electrons shift one side, make it negative, polarize the next door neighbor, and they stick to each other. Bromine boils at 58 degrees Celsius. But one thing I want you to remember from this slide is whether you are hydrogen bonding, dipole-dipole, or London dispersion, you always have London dispersion in you because the electrons move around. So for example, case of water, if I'm going to argue its boiling point and intermolecular, I say it has hydrogen bonding. But then let's not forget this is extreme of dipole-dipole, so it also has dipole-dipole. And finally, any molecule, including this H2O, has London dispersion in it. So we use one intermolecular bonding usually to argue their boiling point, but they have hydrogen bonding has both dipole-dipole and London dispersion. Something that is polar has dipole-dipole, also has London dispersion. A non-polar entity only has London dispersion, nothing else to offer.